Okay, folks, here we go. 2-5 lesson. Great question on what pages it is in your book. Let me look for a second. It is starting on pages 118. So page 118 in your book. 118, 119, 2-5 lesson. We're comparing proportional relationships in different representations, whether it's a graph, an equation, or a table. So you may be wondering how we compare them. Well, this is going to teach you. So, page 118, if you take a look, here's example number 1.
How can you compare proportional relationships represented in different ways? Think about this question during the lesson. Mira is researching cruising speeds of different planes. She has a table of data on the Cessna 310, time in minutes, and distance in kilometers. Mira also has a graph for the Boeing 747.
Table.
The point
Graph.
1, R, represents the unit rate. Which airplane has a greater cruising speed? Let's find the two speeds. First, we should find the cruising speed of the Cessna. How do you find a cruising speed?
Well, we want to find kilometers per minute in this case. How many kilometers is this plane going per minute?
The cruising speed is the same as the unit rate. Mira can rearrange and expand the table to find the constant of proportionality, distance over time.
Folks, hopefully some of these terms that they talk about, constant proportionality, unit rate, ringing a bell from some of the stuff you guys did in 7th grade.
In each column, the constant of proportionality is 8.
The key thing to think about in this situation, anytime it's proportional, if we take what's called the y value divided by the x value, it will always come out to be that same value. That's what determines that it's a proportional situation.
So the Cessna's cruising speed is 8 kilometers per minute. Now, we need the cruising speed of the Boeing 747. To determine the constant of proportionality, Mira can find the difference between any two pairs of coordinates. There are many points on the line, but not all of them have coordinates that are easy to read from the graph. Mira could choose these 2 points, for example. The graph has a run of 2 and a rise of 30. The ratio of rise to run is 30 to 2, or 15. So,
now, folks, we're going to make it a little bit easier than that. We don't even have to find the difference of what they're talking about here because we know this is a proportional relationship. It's a graph that starts at the origin and is in a straight line. All we have to do is take a y value divided by the x value. Okay? 60 divided by 4 is 15. 90 divided by 6 is also 15. It's a proportional relationship, so it doesn't matter which point we use. It's always going to come out to be the same.
The Boeing has a cruising speed of 15 kilometers per minute. The Boeing 747 has a greater cruising speed than the Cessna 310.
We can see that by comparing the unit rates. This one's 15 kilometers per minute. This one's 8 kilometers per minute. Pretty easy to see which one is faster. Okay, take a look down at the try it section, folks. Okay, now we've got a graph. It says the graph represents, let me get rid of this thing. Graph represents the rate at which Marlo makes origami birds. They like folding up things and making little birds. Okay, for a craft fair. The equation y equals 2.5x represents the number of birds y that Josh makes in x number of minutes. Who makes birds at a faster rate? Well, folks, it's real easy. You guys learned, okay, in 7th grade. We can find the constant of proportionality or the unit rate by looking at it at this equation. This is my friend Josh. Okay, Josh, he makes 2.5 birds per minute. Okay, Marlo over here on this graph, because this point or this graph goes through the origin and it's in a straight line, all we have to do is find one ordered pair. Hey, Jelly Rose, come here. Look, everybody, it's Jelly Rose. Jelly Rose coming in. She's going to point to a spot on this graph. Anywhere on the line. It's got to be on the line. On the line. She pointed to this point right here. Now, that point right there has an ordered pair of over 40 and up to 8. Over 40, up to 8. So, we have to figure out how many birds per minute. I don't like the book sometimes because they do things goofy. Either way, if I wanted to find birds per minute, I got to take y divided by x. So, we take 8, we divide it by 40. I'll tell you, this will come out to be 0.2. Or 0 and 2 tenths, as Jelly Rose just said, which just means they can make 0.2 birds per minute. Now, who is making birds at a faster rate? The person who can make 2.5 or the person who can make 2 tenths? Yes, folks, it's the person who can make 2.5. Okay? Good deal. Let's take a look at example 2. Jelly Rose is laughing at us. Here we go, example 2. Let's see what we're looking at here. Okay, we're looking at graphs. It says the graph represents the rate at which Daniel earns points in his video game. The rate Brianna earns points in her video game is represented by the equation y equals 2x, where y is the number of points and x is the time in minutes. At these rates, who will earn 100 points faster? Pretty easy. Let's find a unit rate. Let's see who's earning points faster. Okay? Once again, to find Brianna's unit rate, once again, we can substitute 1 into there for the x value, or we can just look at the coefficient of that equation. That's called our constant of proportionality, our unit rate. Brianna, she's earning 2 points per minute. Daniel, if we look at the graph over there, we can choose any point on that line. They're showing 3 of them. Okay, this first point, we could use this point, we could use this point, we could use any of those points. We'll use this first point, which is the point 1, 3. Okay? Now, in 7th grade, you guys learned about a special point called 1, r. This is your unit rate right here. Okay, so if we have an ordered pair 1, 3, that right there is your unit rate. So, Daniel is earning 3 points per minute. Well, who's going to get faster? The person who gets 2 points a minute or the person that gets 3 points a minute? Jelly, who's going to get there faster?
What is it?
The person who's going to get to 100 faster? The person who gets 2 points each time or the person that gets 3 points each time?
3 points.
The person who gets 3 points. So Daniel's going to get to 100 points faster.
Daniel is the winner.
Daniel would be the winner. Okay, let's go now. I think we're on page 119. Example number 3. Okay, the graph represents the cost per ounce of a granola cereal. The 15-ounce box of raisin cereal costs $3.90. Which cereal costs more per ounce? That sounds like we got to find unit rate. So, cost per ounce. That just means I want to take the cost and I want to divide it by the ounce. Is. Okay? So, if we want to find for the raisin cereal, that would be $3.90 divided by the 15 ounces. Now, $3.90 divided by 15, I should ask Jilly, but she doesn't know. I take $3.90 divided by the 15 ounces. This comes out to be 0.26, which is 26 cents per ounce. Okay? If I look at the granola cereal, this is where we need to try and find a good point, which we want to find a point on that line that crosses at the corner of a grid. This one, no. This one, no. This one, no. That one's good. Okay? Which is the point over 20 and up to 5. Okay, over 20 up to 5. So we need to take the cost divided by the ounces. We need to take the y value divided by the x value. So we need to take 5 and divide it by 20. Okay? This comes out to equal 0.20. Oh, I'm sorry. 0.25 per ounce. Well, which one costs more per ounce? The granola, that's 25 cents per ounce, or the raisin, that's 26 cents per ounce. That's right. Okay, the raisin cereal. Okay, now we go to the try it section. Ooh, this looks good. Let's listen.
The distance covered by the fastest high-speed trains in Japan traveling at maximum speed is represented on the graph. The fastest high-speed train in the United States traveling at maximum speed covers 600 kilometers in 2.5 hours. Which train has a greater maximum speed? Explain.
Okay, let's calculate maximum speed. United States. If I want to find speed, I want to take the distance divided by the time. Okay, distance divided by time. So I need to take 600 miles, or kilometers, sorry, and divide it by the 2.5 hours. That's telling me my unit rate. So I take 600 divided by 2.5. 600 divided by 2.5.
I should be doing math.
This comes out to equal 240 kilometers per 1 hour. That's called our unit rate. Distance divided by time. Now I got to find my unit rate from the lovely graph. Now again, we can look to see at the point 1, r, but this is not a good point for us to estimate this distance. So let's try and find a coordinate pair that crosses exactly on the corner of a grid, which I'm looking at this one right here. This is the point 3 and 1,000. So to find our distance per hour, 1,000 is our distance, 3 is our time. So Japan, we want to take 1,000 divided by 3. There's our kilometers, there's our hours. This will come out to be 333 1/3 kilometers per hour. Now, this is where I call in Jilly Rose again. Come on, Jilly. Which train has the greater speed? The United States, which is 240, or Japan, which is 333 1/3?
Our friend the Japanese.
The Japanese, everybody. She says Japanese. She can look at that unit rate, compare that 333 is greater than 240. Questions on that? I didn't think so. Nobody has any questions. So, folks, there is the 2-5 lesson where we're comparing proportional relationships given to us in graphs, tables, and equations. Next up will be your vocabulary support. Hope you did well. Jilly Rose, you want to say bye?